In this second tutorial, we will solve a quadratic equation over the set of complex numbers using the complete the square method. So here I'm going to show you the steps for how to solve a quadratic by completing the square. And after each step, I'm gonna perform that step with this example. So our first step, we must always divide all terms by the value of a. Now remember that it's ax squared plus bx plus c equals 0. That is our standard form for a quadratic. So the completing the square method will only work if the number in front of the x squared term is a 1. So if we have any other number in front of our quadratic term, our x squared term, we have to divide that number away. And we have to do that to all of our terms. So that's our first step. We don't always have to do that step because a lot of times it'll be a 1x squared to begin with. But if it's not, we have to divide everything by whatever number a is, if it's other than 1. So now we have x squared plus 6x minus 91 is equal to 0. So that's our first step. Our second step is going to be to get rid of whatever number is right here. I'm going to call it the constant. So step 2, add or subtract, it just depends on what we need to do to move it, the constant, that number, to the other side of the equation. I'll say of the equal sign. So in this case, I have a negative 91, so I'm going to add 91 to both sides so that it's on the other side of the equal sign. And I'll be left with x squared plus 6x. Now I'm going to put a little plus blank right here because I know I'm going to be completing the square. And over here I've got 91. And since this is a balanced equation, if I put plus blank on the left side, I should probably put plus blank on the right side. So that's step 2. Step 3 is going to be complete the square. We're going to be using the pattern that we just learned in the previous tutorial. Add to both sides is incredibly important. We're going to find our little magic number that will complete the square, and we're going to add it to both sides. So we want this trinomial to be a perfect square trinomial. And to do that, we're going to take half of this middle number, which is 3, and then we're going to square it to get 9. 9 is the number that completes the square and makes this a perfect square trinomial. Now, if I add 9 to one side of an equation, I better add 9 to the other side of the equation as well to keep it in balance. So that's step 3, complete the square to make this a perfect square trinomial. Step 4, factor the left side, and simplify the right side. So the whole point of putting this, making this a perfect square trinomial is because it will factor into a quantity squared. X squared, I take the square root of that and I get x. 3 squared, I take the square root of that and get 3. I keep that sign, x plus 3 quantity squared. We practiced that in the previous tutorial. Go watch that if you have trouble with that. Simplify the right side, well, that's just adding two numbers together. 91 plus 9 makes 100. Feels nice that that's a perfect square. It won't always happen. That's step 4. Step 5 is what we need to do is get rid of this squared. We have something that's being squared, so we can get rid of that squared by taking the square root of both sides. Step 5, take the square root of both sides. Now, if you're going to introduce a square root symbol into your equation solving, you must remember the plus or minus symbol. I'm going to put 3 exclamation points here. If you put a square root symbol on to solve an equation, you have to make sure that you're taking both the positive root and the negative root. We all know that this is quadratic and that there will be 2 answers. So when I put this square root symbol on here, of course I do it to both sides, the square root of something squared will cancel away and I'll be left with x plus 3. Over here, the square root of 100 is 10, but I need to remember that it's plus or minus 10 because positive 10 squared is 100 and negative 10 squared is 100. So when you put the square root symbol on, you must remember the plus or minus so that you find both solutions. And that's step 5. We are so close to our answers. Finally, step 6, solve for x and simplify if we can. So I'm almost finished. I just have x plus 3. Let's get rid of the 3. I'm going to squeeze that 3 right over here as the first thing. I'm going to have x equals, I'm going to put the negative 3 and then the plus or minus 10. Now this one can actually simplify because these are numbers that we know. I'm actually going to split this up into the 2 numbers that I see because I see negative 3 plus 10, so I'm going to write negative 3 plus 10. And the other one I see is negative 3 minus 10, so I'm going to write negative 3 minus 10. Those will be my 2 answers. Negative 3 plus 10 is 7. Negative 3 minus 10 is negative 13. And I found my 2 answers. Kind of ran out of room there. So I've given you all 6 steps, and of course I've color coded them. Maybe you go back and color code them with some colored pencils if you want to. And we've gone through all 6 of those steps with this one problem. If you get lost in any part of these problems today, go back and refer to the steps and follow those steps in order. I have 3 examples that I'd like to show you in addition to that first one. So here we go. Example 1, x squared minus 10x equals 15. I want to solve this quadratic by completing the square. It's important to note the direction. Today we're completing the square. So it looks like step 1 and 2 have basically already been done for me. I already have 1x squared, so I don't need to divide everything by a, and somebody already put that constant on the other side. What they didn't do is leave some space for my little plus blank, so I'm going to do that. X squared minus 10x, I'm going to put my plus blank equals 15, and I'll put the plus blank on both sides. So now we need to find that magic number that completes the square, and hopefully you're seeing that that's going to be 25. Half of 10 is 5, 5 squared is 25. Put that on both sides, and now we have 25 on both sides. This is a perfect square trinomial, so this will factor into a quantity squared. X, 5, and keep that sign, that first sign, x minus 5 quantity squared. Over here we're going to simplify, that becomes a 40, and so there we are. Now all we have to do is unlock this squared, and to do that we put the square root symbol on, the square root symbol. The square root symbol of something squared will cancel away and we get x minus 5. Over here we have plus or minus the square root of 40. Now this time we do not have a perfect square. So we're going to have to simplify this using our techniques that we've learned in Algebra 1 and geometry. I'm looking at 40 and I'm trying to find the perfect square that goes into 40. Perfect squares are 1, 4, 9, 16, 25. Oops, you know what? I see 4. So I'm going to write this as plus or minus. I'm going to break this apart. Square root of 4 and square root of 10. Because that's a perfect square. So this is plus or minus 2 square roots of 10. Great, so I've simplified the square root of 40 into 2 times the square root of 10. So now I have x minus 5 is equal to this. One last step, I need to solve for x. I'm going to add 5 to both sides. And I'm going to squeeze that in. I like to put it right here at the beginning. So I'll put the 5 and then the plus or minus 2 square roots of 10. And actually we're finished this time because these are not like terms. They cannot be combined. So we are finished. We found our answers. Do you see that there are 2 of them? 5 plus 2 square root of 10 and 5 minus 2 square root of 10. Those are our 2 answers. So we solved another one. Let's see if we can do that over here. Again, it's 1x squared, so step 1 does not need to be done. I already have the 1 here, but step 2 should. Let's subtract the 21, put that over here. That constant has no business being over there. Over here. Let's put a little plus blank. I've got negative 21 and a little plus blank. So what completes the square here? Half of 6, 3. 3 squared, you always square to put it on the blank, 9. I'll put 9 on both sides. This is a perfect square trinomial. It factors into a quantity squared, x plus 3. Over here, we're going to simplify. Negative 21 plus 9 is negative 12. Well, this is kind of weird. I can already see. I have something squared equal to a negative. It's a good thing we learned complex numbers because this can only happen if we're dealing with imaginary numbers. Okay, let's put our square root symbol on there because that's what we're going to do next anyway. We have to unlock this squared. So a square root of something squared cancels away. We get the x plus 3. Over here we have the square root of negative 12, but remember it's plus or minus the square root of negative 12. And now we have to simplify this left side. Negative 12 is not a perfect square. The first thing I need to do, of course, is pull this square root of negative 1 out as a little I. Plus or minus I, square root of positive 12. That feels much better. We can't have negatives underneath the square root, so we pull that square root of negative 1 out, and we make that I, the imaginary number. Now let's see what we have for 12. I need to find a perfect square that's hiding in 12, and you know what? I think it's 4 again. So I've got the plus or minus I, and I'm going to break apart square root of 12 into 4 times 3. So this is plus or minus, this is I, this is 2, so I'm going to write that as 2 times I rather than I times 2, and then square root of 3. Okay, and I'll bring this all the way down here. I've got x plus 3 is equal to this. I just have to subtract 3, and I will be at my answer. Subtract 3, I'm going to squeeze that right up here in the front, and I will have x equals, I'll put the negative 3 first, then the plus or minus 2i square root of 3. So completing the square is a method that works for every quadratic to solve it, including the imaginary answers. Factoring would never have found these answers. Graphing would never have found these answers. So we need completing the square to be able to find our imaginary answers. Factoring would not have helped this one. Graphing would have at least given us an approximate because these are real numbers and that means that it crosses the x-axis, but the calculator would only give us an approximate, a decimal. Completing the square will give us our exact answers. All right, moving right along to our final example. 6x squared minus 6x minus 3 equals to 0. Well, this is the first time that we have something other than a 1 in front of our x squared, so we need to know to get rid of that first. I'm going to divide everything by 6. This has to be a 1 to be able to complete the square. So we have 1x squared, that's nice. This becomes minus 1x. This becomes minus 1/2. And of course 0 divided by 6 is still 0. So that's our first step. Step 2, let's get rid of this constant. It's kind of annoying that it's a fraction, but oh well, we have to be able to deal with fractions some of the time. So let's get rid of that. And I've got x squared minus x. I'm going to put a place for a little plus blank. And over here I've got positive 1/2, and I'll put the plus blank on both sides. So now let's see if we can complete the square, find the number that will make this a perfect square trinomial. Well, this coefficient right now is 1. Half of 1 is half. Square the half. 1 times 1 is 1. 2 times 2 is 4. So 1/2 squared is 1/4. Let's add that to both sides. Lovely little fraction problem. This is a perfect square trinomial, so that will factor into a quantity squared. I know that the x is coming in the front. I know that it's a minus sign, and I know that it's either the square root of 1/4 or the half of the 1. Either way, it's 1/2. Quantity squared equals, now we've got to simplify this. 1/2 plus 1/4. When I'm adding fractions, I need to have the same denominators. And we all know that 1/2 is the same thing as 2/4. So this is really 2/4 plus 1/4, which of course is 3/4. You could check this on the calculator. We're getting a common denominator ultimately by multiplying the denominator by 2 and therefore the numerator by 2. So 2/4. Our next step is to unlock this squared part. So let's take the square root. Squaring a square root, or excuse me, square rooting a square undoes each other, and I get x minus 1/2. I'm not going to forget my plus or minus. The square root of 3/4, I don't like fractions underneath our square root. That's one of the rules for an unsimplified one. So I'm going to write it as the square root of 3 and the square root of 4 individually. That's kind of nice. There's a property that says that I can do that. I'm kind of running out of room here, so I'm going to go on up here. I've got my x minus 1/2 still. I'll deal with that in a minute. Over here, I've got plus or minus. Now, the square root of 3, of course, is still the square root of 3. But the square root of 4, we all know, is 2. So that's kind of nice that the denominator is now a 2 and no longer a radical. One last step. Let's add this 1/2. I'm going to put it right here in the front. And I've got x equals, I'm going to put the 1/2 first, like I said, then the plus or minus square root of 3 over 2. And one last little thing, because these fractions are just dying to be combined together into one, I am going to combine them together. Since they have the same denominators, it's nice. I can do this. 1 plus or minus square root of 3. Now this actually is kind of a gross problem because of all of these fractions. It can be done because we just did it. I showed you using the completing the square. Some people would choose not to complete the square with this, either because they're afraid of the fractions or they just don't want to deal with the fractions. That's why we have one more method to go. The quadratic formula can be used instead of completing the square when you realize that you're going to have fractions in the middle of your work. So that's the beauty of having multiple methods. Completing the square works, of course, but quadratic formula may be a better method to use for this particular problem. I showed you 4 problems in this tutorial. I encourage you to go back and rewatch those 6 steps if you got lost in any part of them, and I will see you in class to practice this material. Thanks for watching. Please note any questions that you still might have somewhere off in the margins of your note sheet so that you be sure to ask your partner or myself in class next class.